Okay, so the multiplicity of these zeros, we have an x squared here, so the multiplicity of this 0 is 2. I'm going to write this on the side, multiplicity. All the other factors have an exponent of 1, so all of them have a multiplicity of 1. And we can always double check if we add up all of our multiplicities, we should end up with the same degree that we started with, which is a 5th degree polynomial. So now I'm going to go on the next page and we are going to summarize all the things that we have. This is a 5th degree polynomial. Leading coefficient is a positive 2. End behavior, because it's an odd function, we know it's going to go something like this. So it starts from quadrant 3, going off and up into quadrant 1. The zeros are 0, negative 1/2, positive 3, and negative 3. 0 has a multiplicity of 2, but all the rest of them have a multiplicity of 1. The y-intercept, we said, because it doesn't have a constant term in this equation, the y-intercept is at 0, 0, so it matches this x-intercept as well. And where the function is positive and negative, it'll be easier for us to do this by drawing a picture first and then writing the intervals. So I'm going to zoom in on my grid. I'm going to draw the zeros. So negative 3, positive 3, 0, negative 1/2. Now, all of these are odd multiplicity with the exception of 0. So what this tells me is I'm going to have a bounce at 0 and a cut through at all the other points. Because this is an odd function, I know that the end behavior will go up and to the right after the last intercept and down and to the left before the first intercept. So cut through with a bounce at 0. So I'm going up here, down here, bounce at 0, and then through the others. So that's what my graph will look like. So when I'm looking for intervals of positivity and intervals of negativity, we are looking for y values that are negative and positive. So where is it positive? It is positive between the first two intercepts. So from negative 3 to negative 1/2. And also it is positive after the last intercept. So 3 less than x, or x greater than 3. Those are where the function or the y values are positive. So that's the yellow shaded area. And then for the negative bit, we have x must be less than negative 3 and between negative 1/2 and positive 3. Those are where the negative y values are. So this is kind of a summary. This is not an accurate graph, obviously, because I don't know the in-between points, but I know that the general shape will look like this. So this is a sketch of the graph using the key points that we can tell from the equation. In my last example, I have a quartic graph, y equals x to the power 4, and it is transformed to obtain this function. So this is a reminder of what we did in Unit 1. This is the transformations unit. Now the base function of x to the power 4 is kind of like a U shape. It's very similar to a parabola, like a quadratic, but the numbers are slightly different. So for example, if I did a quick table of values, 0, 0 still exists, 1, 1 still exists, negative 1, 1 still exists, just like a quadratic. However, once I get to 2, negative 2, 2 to the power 4 is 16, so it jumps up very high very quickly. But the general shape, the base shape of a graph is similar to a parabola. So in this question, we are asked to state the parameters and describe the transformation. So what happens at each point? Complete the table of values that's on the next page and then sketch the graph of what we think it might look like. So the summary of the transformations is right here. So I'm just going to rewrite the equation on top of our page so I don't have to keep scrolling back and forth. So we have negative 1 over 2 x plus 1 to the power 4 and minus 4. And I just put the exponent right here. Okay, so our function is x to the power 4, and all the stuff in between is transformations. So remembering what we did in Unit 1. The b value is right here. It's negative 1/2. This represents a horizontal expansion by 2 and a reflection over the y-axis. So it's backwards. A is our front numbers, so that's a 3. This represents a vertical expansion by 3. H is negative 1, right? Because in our base function, we always write x minus h. So because that 1 is positive, I know h is negative 1 because it's minus and negative 1. That tells me I have a horizontal shift left 1. And then my k value is negative 4, so I'm going down 4. So in the chart, it's asking us to essentially map the coordinates. And the chart is asking us to do one piece at a time, which I'm not going to do. That's going to take too long. So let's just cross that out. Let's just write, what would the mapping notation of this be? If I have my base coordinates x, y, using these transformations, what am I doing to each of the values? I have negative 2x minus 1, so reflection, expansion, shift left for the x, and then 3y minus 4 for the y. So if I use this, and my original coordinate is negative 2, 16, I'm going to use my calculator to put negative 2 here and 16 here. And I should get, oh, let me grab my calculator here actually. Negative 2 times negative 2 minus 1. And then 3 times 16 minus 4. So this gives me the values 3 and 44 is my new coordinate. Then I do the next one, negative 2 times negative 1 minus 1, 3 times 1 minus 4. This gives me positive 1, negative 1. And for 0, 0, that one's a little bit easier. This is going to be negative 1, negative 4. For 1, 1, this is going to be negative 3 and negative 1. And lastly, we have negative 5, 44. Okay, so I'm mapping my original coordinates to my new coordinates, and I'm using the mapping notation that I wrote up here. Okay, so using the rules for transformations that we learned in the last unit. So sketching this graph, these numbers are pretty big. So again, we're not going to get a completely accurate one, but we can do a bit of a sketch as to what the general shape will look like. So negative 3, negative 1, negative 5, 44. Okay, so taking a look here, negative 1, negative 4. I'm starting here because I know this is my vertex. If I go back to the original equation, when we do this kind of transformation, the h and the k in this standard form is going to give us the coordinates of the vertex. So I know that this is going to be essentially the center of my graph. So negative 1, negative 4 is right here. And then positive 1, negative 1 is going to be there, and then -3, 1, 2, 3. So it's kind of starting to look like my parabola. And then at +3, 44 is like way up there somewhere, way up there somewhere. But essentially our U shape has been transformed to something that looks like this. Not super accurate, but again, this is just a sketch based on the information that we have. As long as you're able to determine the key points and draw the general shape of your graph, then you're good to go.